Okay. Good morning, guys.
Good morning.
Good morning.
Have you completed the last problem, everyone? If yes, just give me the values. What is QS and so on. Yeah. Okay. So have you calculated QS?
98.02.
How much?
98.02.
98.02. Any other things like 10 to the power of 3 or something?
No, sir.
Okay. So kilojoules per minute, isn't it? Now QS is done. Later on, we have to calculate QBP. It is nothing but the value of PP. But the thing is, the value of PP should be in kilojoules per minute. That you have to take care. Okay. So originally the BP value would be in what? Kilowatts, isn't it? Why the permission is being asked every time? Okay. Originally it would be in kilowatts, that is kilojoules per second. So what you have to do is you have to convert this to kilojoules per minute. So that is your task. Once you convert, you can put the value here. Okay. So what is the value? QBP. So how did you get this value? Let me cross verify with the values which I have got before going to QBP. Okay, just we shall check this. Okay, so QS is nothing but what? It is EMF dot into CV, isn't it? Now, what is the value of EMF dot you have?
16.0.
CV is 22. Okay, 22,000 kilojoules per meter cube it is. Okay, so you have the value of CV as how much? It is 22,000 kilojoules per meter cube. So it's better that you substitute the value of MF in meter cube per second or meter cube per minute. Okay. So if you substitute meter cube per minute, now check the values. It is EMF dot into CV. So EMF dot is what? Meter cube per minute cross CV is kilojoules per meter cube. Kilojoules per meter cube. Now meter cube goes away. So whatever answer you get, that would be in kilojoules per minute, which is the required value, because this is the value this is the unit which you have to take care of. Okay. So now for that, what you have to do, you have to substitute the value of mf in meter cube per minute. Okay. So what is the value you have got? mf, you have an 13 meter cube per hour, isn't it? You have the value as 13 meter cube per hour. So what I have to do, so that I have to convert this to meter cube per minute.
Divided by 60.
So it is 13 divided by 60. So this is mf dot, isn't it? Very good. Now substitute this value and this value so that your end result would be of this unit. Substitute it now. So qs is equal to mf dot is 13 divided by 60 cross cv is 22,000. So now whatever answer you get, that would be in kilojoules per minute, which is required. Now give me the value.
Four seven six six point six
4.76 into 10 raised to 3.
4.76 into 10 raised to 3.
Into 10 raised to 3.
Okay, now I will change this. Okay. So 4.76 into 10 to the power of 3 is the value. Okay, now it is correct. Got it, Aditya? You were wrong, isn't it?
Yes.
You forgot about the units. So units play a very important role. Now QBP, guys. QBP, I already told you, whatever the value you get, it should be in kilojoules per minute. Okay, because it has been asked to calculate the values in per minute basis. Okay, so remember, the value of QBP is nothing but the value of BP itself, but the BP would be in kilowatts. Okay, that you have to convert into kilojoules per minute. Okay, convert and give me the value. I need answers from everyone, guys. Okay.
0.625.
0.625. Okay. 0.625 into 10 to the power of 3. Is that the value correct? Just check. So what is the value of BP you have got? The value of BP is how much? 37.5 kilowatts, right? So BP in the sense, so this is 37.5 kilowatts. So kilowatts in the sense, again, it is 37.5 kilojoules
Divided by
per
60.
second.
Divided by 60.
So you should not divide by 60, rather you have to multiply by 60, because it is conversion of second to minute. Okay. So 37.5 cross 60, then it would be kilojoules per minute. Okay. So now what is the value in kilojoules per minute?
(2.25 into 10 power 5).
2.25 into 10 to the power of 5.
3.
3.
Okay. So it is 2.25 into 10 to the power of 3. That is the value which we have arrived at. So 2.25 into 10 to the power of 3. Same thing I would update here. Correct. 2.25 into 10 to the power of 3. That's great. Now, heat loss due to cooling water. Any cooling water parameter given? So QCW, how would you calculate this? You would calculate it as mass flow rate of water cross Cp of water cross temperature difference of water. So what our parameters are given?
Mass flow
Mass
rate and
flow rate
temperature
of water is
difference.
given. How much?
625 kg.
625 kg, but it is per hour or per minute or per second. What it is? 625 kg.
Per hour.
It's per hour, right? So I need the value when kg per minute, since it is a minute basis calculation, right? So I would convert this into kg per minute. So what I have to do?
Divided by 3000.
Divided by 60.
Oi, 3660.
3000.
60.
Minute, second Allah. Be careful about
Sorry,
this.
60.
So it is 60. So mass flow rate you have calculated. I told you in the last problem that Cp of W have to be remembered. How much is that value? It is 4.18 kilo joules per kg Kelvin. So this is the value that you have to remember. Okay. And I think delta T of water is given. How much is that? Temperature difference of inlet and outlet water. How much is the value? So it's 35. Now substitute all the values. MF dot is 625 cross divided by 60 cross. Cp of water is 4.18 cross. Delta T of water is 35. So if you substitute all this, whatever answer you get, that would be in
Sir, the
kilojoule. Temperature.
We no need to convert for Kelvin.
Yes, I would say you. So this is the difference. All of you observe this. This is very important to understand. Okay. So this is the temperature difference. So delta T of water in the sense, ಏನಿದು ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ಎಲ್ಲರೂ. ಒಂದು engine ಇರುತ್ತೆ. There will be an engine. Okay. Now, for this engine, you will supply a cooling water to cool the engine. Correct? And this particular cooling water would get heated up and come out, isn't it? So the temperature at the inlet of cooling water is T water, temperature of the water at the inlet. Similarly, the temperature of the water after it has cooled, it increases its temperature naturally, isn't it? So the temperature of the water at the outlet is TWO. Now, what is this delta TW? So delta TW is nothing but the difference between these two. For example, it is TW at outlet minus temperature of the water at the inlet. Okay. So cumulatively, he has given this particular parameter as 35 here. Understood? Now, if I increase it to Kelvin, suppose, say, the difference is 35, no? The temperature at the outlet of the water, assume it is 135. Okay. At the inlet, it was 100. Now, what is the temperature difference of the water from inlet to outlet? 35, isn't it? Now, what you do, you convert the values into Kelvin. So 135 plus 273, how much is the value? How much is the value? 135 plus 273.
408.
408.
408. Now, 100 plus 273 is 373, isn't it? Now, you make a difference between these two values in Kelvin. 408 minus 373.
35.
35. Does it make a difference if I substitute in Kelvin there?
No,
So that is why whenever there is a difference in temperature or whenever there is a change in temperature is given, so you have to substitute the value, because carefully observe, I've not even mentioned the units also here. Okay, it is not degree Celsius nor degree Kelvin. It is just the difference. When there is a difference, no need to convert it to Kelvin nor Celsius nor Fahrenheit. It doesn't make sense. Is that clear? Whenever there is a difference or whenever there is a change of temperature given. Clear, everyone? This is very important to be understood. Clear, right, Aditya?
yes, sir.
Now, QCW, guys.
1.5 to 10 power.
1.52 into 10 to the power of
3.
3. Okay, same thing I would just mention here. It is 1.52 into 10 to the power of 3. Now, unaccounted heat. How will you calculate unaccounted heat? How will you calculate unaccounted heat?
QS minus QBP plus QCW.
Very good. So it is QS minus the whole thing. The supply minus source minus consumption. Source is QS. Consumption is where you have consumed. You have consumed in BP plus QFCW. Okay. Since there is no exhaust gas, we shall end up here. Substitute all the values and give me the value of QUA, which is unaccounted. Again, it would be in kilojoules per minute itself.
9.9 into 10 power 3.
9.9. Sure. Here it is.
0.9. 0.99.
That's what.
0.99 into 10 power 3.
0.99.
0.9 into 10 to the power of 3. Now, substitute the same value here, 0.9 into 10 to the power of 3. Now, add these all values in the sources. Only you have heat supplied with the fuel, that is the source. So it is just 4.76 into 10 to the power of 3. Now you add all this, 2.25, okay, plus 1.52 plus 0.9. What is the value? Again, it has to be the same value. Is it correct? So that the source would be equal to the consumption. It has to be balanced. Okay, now what you have to do, you have to calculate the percentage. How to calculate the percentage? This particular value divided by this value into 100.
$47.26.
47.2% is being entertained in BP. Next, how much is the percentage of heat loss due to cooling water? For that, what you have to do? This divided by this into 100.
31.9.
So it is 21.9% of heat is lost because of cooling
31.9.
water.
31.9.
31.
Okay, 31.9 percentage of 31.9. 31.9 percentage of heat is lost because of cooling water. Now, what percentage of heat is lost is unaccounted? Okay,
18.9.
18.
Unaccounted is 18, isn't it? Okay, add all this, it has to be 100 again. So when this particular heat balance sheet is totally tallied, the supply must be equal to the consumption. Then your heat balance sheet is done. Then you'll get full marks. Even you will come to know that whatever problem you have solved is correct. So this particular values must be equal to this particular value. And summation of all this should be equal to 100. Is that clear with this particular problem? Any doubts in this problem?
No.
Okay. So next you go for this particular problem here. Take down this. We will solve this. I think it is the same problem again. No new thing in this.
Excuse me, sir.
Yes.
Previous problem that heat output will get 4.67.
Which one?
That heat output.
Heat output in the sense?
Sir, total.
This thing, sir. That 2.25 plus 1.52 plus
Acha,
0.9.
total you're talking about. Heat output total. How much you'll get?
Yes, sir. 4.67.
little bit marginal. So 4.76, isn't it? Here it is 4.67 you're talking about. So a little bit marginal would be there because you're using your calculators and you will be neglecting the decimal points to some extent. Definitely that particular change would be there. No need to worry about it. Okay.
Okay, sir.
Yeah.
Okay.
Now you take this problem. I want everyone to solve this. I would ask any one of you. Okay. Just try this.
Sir,
Yes.
sir, it's recorded video won't open in the YouTube, sir.
Why? I would just check.
Sir, yesterday I sent the screenshot, no, sir.
Yes. I have seen it. I would just check it. You'll be taking this particular problem. I would check that now. Okay.
Okay, sir.
Yeah. Google Classroom. It's opening for me. Just check. Okay, what I will do is I'll just open it on YouTube. I would share the link here. Okay, share, copy, chat box. Okay, now you just check this particular link. This is the first video I have posted. Problem number 1. And this is problem.
Sir,
Yes.
question dictate
Video
ಮಾಡಿ.
unavailable.
ಡಿಕ್ಟೇಟ್ ಮಾಡ್ತಾರೆ ಎಷ್ಟು ಅರ್ಥ ಆಗುತ್ತೋ ಅಷ್ಟು ಬರೀರಿ ಓಕೆನಾ ಐ ವಿಲ್ ಡಿಕ್ಟೇಟ್
It's not opening, sir, video.
what is the error that you are getting, guys?
This video is
Video unavailable.
This video is private, sir.
Private. Okay, so then what I have to do is I have to go and change the settings, I guess, right? For me it's opening. Okay, private it is. Okay, now how to change this? Any idea, YouTube experts here? Your videos. Okay, channel content. That's model 1. Okay, public, publish, public, publish. Now you check, guys. Now you just check. And this is problem number 2. And problem number 3.
It's opening, sir.
It's opening, right? Problem number 3. We forgot to record it. Okay. Scribe. Okay.
Sir, ನಾನು
Clear, right?
ಅರ್ಜಿತ್ ಸಿಂಗ್ ವಿಡಿಯೋ ಪ್ಲೇ ಆಗ್ತದೆ.
ಏನಪ್ಪ? ಏನಾಯ್ತು?
ಅರ್ಜಿತ್ ಸಿಂಗ್ ವಿಡಿಯೋ ಬರ್ತಾ ಇದೆ.
ಅರ್ಜಿತ್ ಸಿಂಗ್ ಇನ್ ವಿಡಿಯೋ ಬರ್ತಾ ಇದ್ದಾನ?
ಇಲ್ಲ ಸರ್, ಸುಳ್ಳು ಹೇಳ್ತಿದ್ದಾವ.
ಏಯ್ ದನಕಾಯನೆ. ಕರೆಕ್ಟ್ ಉಂಟಲ್ಲ ಎಲ್ಲ? Okay. Let us start the problem then. Okay. ಅವನು ಸಾಂಗ್ಸ್ ಸಿಂಗರ್ ಅಲ್ಲ ಅವನು, ಹಾಗಾಗಿ ಯಾವುದೇ ಲಿಂಕ್ ಓಪನ್ ಮಾಡಿದ್ರು ಬರೀ ಅರ್ಜಿತ್ ಸಿಂಗ್ ಸೋನು ನಿಗಮ್ ಕಾಣ್ತಾರೆ ಅವನಿಗೆ. ಏನ ನರೇಂದ್ರ? Start intro problem. Okay. Let us write down the given data. I'm reading it. Okay. So what are the given data? It's the 4-cylinder gasoline engine, he says, and on the 4-stroke cycle, he says. So what are the different things he has given? He has said it is a 4-cylinder engine. Okay, it is a 4-cylinder engine, and it is a 4-stroke engine. Right now, the base of the engine cylinder is 70 mm, and the stroke is again engine parameters he has given. Okay, so engine parameters is what? Diameter is how much? Diameter is 70 mm, I guess. 70 mm in the sense in terms of meters, how much it is? In terms of
0.07
meters. Okay. Next, stroke he has given. Stroke is 90 mm in the sense that is 0.09 meters. Clearance volume per cylinder, he says. Okay. I wrote down this very clearly. VC, clearance volume, is 70 cc in the sense that is 70 centimeter cube. It is per cylinder. Okay, per cylinder, the clearance volume is so and so. At a speed of, so speed he has given, the engine speed is 3,500 RPM. Okay, the fuel consumption he has given, so fuel consumption EMF dot, that is equals to 20 kgs per hour. Okay, and the torque developed, so again, brake drum parameters he has given. So I would just draw a brake drum. So torque developed, so cumulatively, directly he has given the torque itself. So no need of brake drum also here. So directly he has given the torque for us. So torque is how much? 150 Newton meters. So directly he has given the value of torque. That's great. Next, the CV of the fuel he has given. So calorific value of the fuel is 42,000. Okay, kilojoules per kg. So this is the value. Next is IP of the engine cylinder. Oh, indicated power he has given. Indicated power is 72 kilowatts. So even indicated power he has given. Very good. Now, what you have to calculate is, so to find, what all you have to find? Number one, you have to calculate the brake power. Second, you have to calculate the brake mean effective pressure. Third, you have to calculate the brake thermal efficiency. Fourth, you have to calculate the relative efficiency. And fifth, you have to calculate the indicated specific fuel consumption. So all these parameters you have to calculate. One by one, let us see. Okay. Let us go with the solution. Solution. Any problem in calculating BP? So how do you calculate BP, guys?
Two pi nt by 60.
So 2 pi nt
2 pi nt by
divided by 60. So you have the value of n, you have torque, just substitute and get the value. 2 pi n is 3,500 cross. Torque is 150 Newton meters already. So just substitute and give me the value in watts or kilowatts.
54.97 kilowatts.
54.97 kilowatts. That was easy. Next, what do you have to do? You have to calculate. This was first, isn't it? Next, what you have to calculate? The brake mean effective pressure. So how do you calculate brake mean effective pressure? Darshan S. Shetty. Darshan S. Shetty. How do you calculate brake mean effective pressure? How do you do as Srijan, Hazim, Hashif? How do you do that? How to calculate brake mean effective pressure? First of all, where will you find the mean effective pressure? Where will you find the mean effective pressure? In what calculation will you find the mean effective pressure? BP ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಮೀನ್ ಎಫೆಕ್ಟಿವ್ ಪ್ರೆಷರ್ ಬೇಕಾ ಅಥವಾ ಐಪಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ
BP.
VP sir, VP.
IP calculate ಮಾಡಬೇಕಾದ್ರೆ you require a mean effective pressure, that is plan divided by 60, something like that. Okay, now so whatever the mean effective pressure you are finding here, it is called as indicated mean effective pressure. Get it?
Yes.
Everyone? So that is indicated mean effective pressure. So what you have to do so that I calculate brake mean effective pressure. So I want brake mean effective pressure now, which is something like this. PM brake mean effective pressure. What I have to do?
Replace PM by.
Replace. Okay, I have replaced. Everything else remains same. It is divided by 60. What else?
That 4-stroke into 4.
Okay, we will take care of 4-stroke and 4-cylinder later, but I want this particular concept to be understood. So now, if I replace IP with the value of BP, then whatever the mean effective pressure you are using is known as the brake mean effective pressure. Okay, it is, if you just use the IP formula, then whatever the mean effective pressure is there within the IP, that is known as indicated mean effective pressure. But if you replace IP value with BP, then whatever the mean effective pressure is there, that is known as what? The brake mean effective pressure. Are everyone clear about this?
Yes.
Yes, sir.
Everyone. So now I have to draw this particular thing. Now, what is the cylinder condition given? It is 4-stroke and 4-cylinder, isn't it? For 4-stroke, 4-cylinder engine, so what is the modification that you require to do? What do you have to do?
Divided by 60 into 4.
Oi, divided by 60 into 4. Enik 4?
2.
So you have to divide it by 2. So now the 4-stroke is taken care of. Now, I have to make this formula for the 4-cylinder. So what I have to do?
Multiply in 4.
Very good. So you have to multiply this whole thing by 4. Now the 4-cylinder is taken care of. Now take this particular formula here. Okay. So BP is equal to brake mean effective pressure cross LAN divided by 60 cross 2 into 4, and this particular formula is for 4-stroke 4-cylinder engine. Now I guess all parameters you have, just substitute the values. So what is brake power? Brake power is 54.97 into 10 to the power of 3. That is equals to brake mean effective pressure you must calculate. Cross length is 0.09 stroke. Area is pi by 4 d square. So d is 0.07, its whole square. Cross n is how much? 3500 rpm. So this whole divided by 60 cross 2, and you multiply this whole by 4. So from this, what is the value of brake mean effective pressure in terms of whatever you get? That would be in Newton per meter square. I think on the 20 minutes ago. Yes, what is the value left?
1.36 into 10 to the power 3.
1.36 into 10 to the power of
3.
I guess the value is wrong.
10
It
power
has to be at least somewhere near 5 or 6.
Sir, 1.36 into 10 power 6.
1.36 into
55.53
power
into 10 power 3, sir.
Sushant, ನೀನ್ ಯಾವುದೋ ಒಂದು value ಹೇಳ್ತಾ ಇದ್ದೆ,
Yes, sir.
55 point.
Sir, 1.36 into 10 power 6.
Okay, so how many of you got 1.36 into 10 to the power of 6? Raise your hands. Okay, only 2. Azim,
1.36 only.
Darshan Shetty, Marwan, Mohan also. Okay, fine. Okay, fine. So let me fix on to this value. Even in my book also it was 1.36 into 10 to the power of 6. Adi correct unta iga? Mistake agid correct?
Yes, sir.
Yeah.
Yes, sir.
So second one is done. So next is third one. What is third one which was asked? The brake thermal efficiency. Okay. So brake thermal efficiency. Hegappa calculate ಮಾಡೋದು brake thermal efficiency? What is the formula? BP divided by MF into CV. BP value we already have. So what is the value of EMF? EMF value is 20 kg per hour. Next, CV value is what? CV value is 42,000 kilojoules. Yes, 42,000 kilojoules per kg. Now, in what units I require MF to be in? Yes, in what units I require MF to be in? Whether should I substitute in kgs per hour, kgs per minute, or kgs per second? So since I have the value of BP in kilowatts, I require even the MF dot CV to be in kilowatts. So if that has to be in kilowatts, in what I have to substitute the value of MF?
We have to convert it into kg per second.
Very good. So convert into kgs per second. How do you convert it? 20 kgs per second I have to do. So divided by
3,600.
now all the values. So kilowatts BP. BP value is how much? So it is 54.97. The substitute rate MF dot is 20 divided by 3,600 cross CV value is 42,000 nav. So what is the break thermal efficiency there in terms of percentage into 100?
%19.63%.
19.63%.
63.
Okay. 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 Next, what do you have to calculate?
Sir, I got 23.55.
Okay. So which one is the correct value?
I also got
23.5.
23.5.
23.5.
23.5. So most of you are getting 23.5 ಅಲ್ಲ?
23.5.
ಓಕೆ ತೊಂದರೆ ಇಲ್ಲ. ಯಾರದು ಹೇಳಿದೆ ರಾಂಗ್? ಅದು ರೆಕ್ಟಿಫೈ ಆಯ್ತಾ ಏನಕ್ಕೆ ರಾಂಗ್ ಬಂದಿದೆ ಅಂತ?
Yes sir, ಕ್ಯಾಲ್ಸಿ ರೇಡಿಯನ್ ಅಲ್ಲಿ ಇತ್ತು.
ಓಕೆ ಫೈನ್. ಈಗ ಫೋರ್ತ್ ಒನ್ ನಾವೇನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? ರಿಲೇಟಿವ್ ಎಫಿಷಿಯನ್ಸಿ. ಓಕೆ, ಸೊ ಇದು ಸ್ವಲ್ಪ ಹೊಸ ಕಾನ್ಸೆಪ್ಟ್ ಇದೆ. I require everyone to listen now. Okay, so what is relative efficiency? Relative efficiency is nothing but actual efficiency divided by theoretical efficiency. So what it is? What do you mean by relative efficiency, everyone? It is actual efficiency divided by theoretical efficiency. Now, ಈಗ ನೋಡಿ, actual efficiency already one efficiency you have calculated. So actual efficiency in the sense what is literally happening. For example, it might be the break thermal efficiency, or it might be the indicated thermal efficiency, or it might be the mechanical efficiency. So what is literally happening when you take the parameters like all this? What is mass flow rate? What is CV? What is BP coming out? What is IP producing? So if you take all those parameters and calculate your efficiency, that is actual efficiency. So actual efficiency can be either of the one. It could be mechanical, it could be indicated thermal, or it could be break thermal. It's up to you which one you take. Since we have already calculated the break thermal, shall I take the break thermal itself? Or I can even calculate the mechanical efficiency and take the mechanical. So it's up to you. We will all follow one thing. Okay. Should I take the break thermal or what? So I would write here efficiency actual. Okay, I'll just write down. So efficiency actual might be what? It might be mechanical efficiency, or you can take the value of indicated thermal efficiency, or you can take the value of break thermal efficiency. So which we will take? We can calculate all three with the given parameters.
Break thermal.
We would take break thermal since we have already calculated. So selecting efficiency actual to be efficiency break thermal. So what is the value which you already got, which is 23.5%. Now, actual efficiency is now done. Now, what do you mean by theoretical now? So theoretical efficiency is something which you calculate by use of a PV diagram. Okay, how the theoretical efficiency you will calculate by use of a PV diagram. For that, you'll be having many formulas. For that, you have to remember it. Okay, so theoretical efficiency is given as is nothing but the air standard efficiency. Okay. In the first part, you have derived the expression for this, since we have not covered the first part. Okay. I will just change the color of all this so that it's a new concept, no? Color. Right. Now, so it is air standard efficiency. Air standard efficiencies of all the cycle. It might be auto, diesel, dual. All the cycles we have calculated in the previous part. Since we have not dealt with it, I would give you the formula to calculate it directly. So it is 1 minus 1 divided by RV to the power of gamma minus 1. So this is the air standard efficiency formula that you have to remember. Okay. So this was derived, and even the problems also will be solved when you take up this particular part of the module. So since we are not covering it, you can just remember this particular thing. Is that clear? Okay, now I would define what is RV. Okay, RV is nothing but it is compression ratio. What is RV? This is important to be understood. What is RV?
Compression.
It's a compression ratio. So what do you mean by compression ratio? It is volume before compression divided by volume after compression. Okay. Now, what is this volume before compression, volume after compression? Let us draw a diagram of an engine. So this is an engine. So before compression, the engine piston would be somewhere here, correct? The engine piston would be somewhere here. And immediately after compression, the piston would be somewhere here, right? Okay, the piston would be somewhere here. And whatever the volume you have here, for example, I would just highlight here. Okay. Whatever the volume you have here, this much amount of volume is nothing but what? You know this, guys. This particular volume is known as what? Yes. So this position is top dead center, and this position is bottom dead center. Okay. Now this particular volume at the TDC before compression, after compression, so only small amount of clearance volume would be there. I would call that as what? The clearance volume. Correct? Understood? So there is a clearance volume. So what is swept volume? Swept volume. So clearance volume would be there here also, right? Borrow highlighter. So this one is also a clearance volume. I would just mark it as VC. And whatever the piston is being sweeping all around. So it would be moving up and down, up and down, up and down, up and down, isn't it? But it is sweeping all this volume. So this particular volume, which I am highlighting now with a different color, okay, is what? Is the swept volume. So what is this? This is swept volume. Okay. So this particular volume is swept volume. Got it, everyone? Now you have to say me to calculate RB. I told you it is volume before compression. Okay. So which one is volume before compression here? The first figure or the second figure?
Second figure.
First one.
Volume before compression. So this is volume before compression is the first figure, right? And what is volume after compression?
Second one.
Second one, correct? So this is volume after compression. Okay, good. So this is volume after compression. Now, can I write volume before compression? So volume before compression in the sense it is VC plus VS. Am I right? But once you compress piston from BDC to DDC, only VC would remain at the top. So volume after compression is VC and volume before compression is VC plus VS. Am I right about this? Everyone understood why I have taken like that? Hey, ಅರ್ಥ ಆಯ್ತೇನ್ರೋ?
Yes, sir.
So volume before compression is the whole volume, clearance volume plus the swept volume. But volume after compression is only the VC. Okay. Now, I should calculate what is VC and I should calculate what is VS. Correct? VC is being given in the problem, I guess, right? Is the value of VC given?
Yes, sir.
How much is that?
70 centimeters.
70 centimeter cube.
70 centimeter cube, and he says it is per cylinder. Okay. So, how many cylinders do I have?
4.
So, it is 70 cross 4 centimeter cube totally. Now, I need centimeter cube to be converted in meter cube. So, what should I do? What should I do to convert centimeter cube into meter cube? Okay. Centimeters to meters, hey, convert martira. How do you convert
100.
centimeters to meters? Into 10 to the power of minus 2, isn't it? Am I correct?
Yes, sir.
Yes, sir.
Similarly, now, listen here. You have to convert centimeter cube to meter cube. So what you have to do is, you have to raise this power to cube again. Understood?
Yes, sir.
So it is 10 to the power of minus 2 into 3. It is minus 6 meter cube. This is VC. Understood, everyone?
Yes, sir.
Yes, sir.
Okay, now, ಈಗ ನೋಡಿ VS. The VC ಆಯ್ತಲ್ಲ, ಈಗ ನಾವು VS. VS is what? Swept volume. Any idea do you have to calculate, how to calculate the swept volume? Any idea?
Total volume minus VC.
Total volume ಎಲ್ಲಿದೆ ನಿಂಗೆ? ಕೊಟ್ಟಿಲ್ಲಲ್ಲ. ಕೊಟ್ಟಿಲ್ಲ ತಾನೆ? See, what do you mean by swept volume? This particular volume, right? ಈ ಒಂದು ವಾಲ್ಯೂಮ್ ನ ನೀನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀಯಾ? ಇಟ್ ಇಸ್ ಇಂಜಿನ್ piston something like this, okay, and this is a circular. If I take it out, it would be something like this, correct? Idu diameter, idu length. So how do I calculate the volume of this swept volume? Can I write it as pi d square by 4 cross L? Swept volume. ಬರಿಬಹುದು ಹಾಗೆ.
Yes, sir.
So Vs is equal to, so it is pi d square by 4 cross L. Okay. Now, this is for one cylinder. ಎಷ್ಟು cylinders ಇದಾವೋ ಇಲ್ಲಿ ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ? How many cylinders you have?
4.
So 4. So should I multiply this by 4 again?
Yes, sir.
So now substitute and give me the value of Vs, guys. So pi d square by 4. So pi, what do you mean by d square? D is the diameter of the cylinder. ಎಷ್ಟಿತ್ತು ಅದು ಏನೋ ಇತ್ತಲ್ಲ ವ್ಯಾಲ್ಯೂ. So it is 0.07. Correct? So it is 0.07, its whole square divided by 4 cross L. L ಎಷ್ಟಿತ್ತು? 0.09. 0.09. Okay. Now this whole multiplied by 4, since it has the 4 cylinders in it. Give me the value. So what is the value of Vs?
1.385.
1.385 into 10 to the power of
-3.
-3.
-3. Correct? Huh?
Yes.
Now, once you have got Vc and Vs, calculate the value of Rv now. So Rv is equal to Vc plus Vs divided by Vc again. So it is equal to Vc esto. It is 280 cross 10 to the power of -6 plus Vs is to 1.385 into 10 to the power of -3. This whole divided by Vc again, it is 280 cross 10 to the power of -6. From this, what is the value of Rv?
5.94.
5.9.
5.9. Any one more? Give me the one more decimal point. 5.9.
946.
946. So I would take it as 5.95. Okay. So Rv bantu. Once you have got the value of Rv, take that particular formula there. So efficiency theoretical is nothing but efficiency air standard and that is equal to 1 divided by 1 minus RV to the power of gamma minus 1. Gamma value name. What is the gamma value?
1.4.
Very good. So it is 5.95. It's whole to the power of 1.4 that you have to remember. That's why I have written in red there. Minus 1. Calculate mighty. So efficiency theoretical ಎಷ್ಟು ಬಂತು? So once you have got efficiency theoretical in terms of percentage, next you can go and calculate your relative efficiency. Relative efficiency is what? Efficiency break thermal and divided by efficiency theoretical. So break thermal efficiency already calculate maduntala 23.5. So 23.5 is whole divided by theoretical ಎಷ್ಟು ಬಂತು? How much is the value of theoretical?
Minus 0.96.
Minus
Yes, sir. Minus it is.
Yes, sir.
Minus 0.96.
minus ಹೆಂಗೋ ಬರುತ್ತೆ? Oh,
51%.
ರಾಂಗ್ ಆಗಿದೆ ಕಣ ಫಾರ್ಮುಲಾ. ರಾಂಗ್ ಬರ್ತಿದ್ದೀರಾ? It is 1 minus 1 divided by RV to the power of gamma minus 1. So 1 minus 1 divided by 5.95 whole to the power of 1.4 minus 1.
0.51, sir.
0.51.
51% ಆಗುತ್ತಲ್ವಾ?
Yes, sir.
So theoretical 51 ಆಯ್ತು, ರಿಲೇಟಿವ್ ಎಷ್ಟಾಯ್ತು ಈಗ? ಓಕೆ ಪ್ರತೀಕ್ ಆಲ್ರೆಡಿ ಇದ್ದ. ಪರ್ಸೆಂಟೇಜ್ ಹೇಳ್ರ ಲಾಸ್ಟ್ ಫೈನಲ್. ಇಲ್ಲಿಗೆ ಕ್ಲೋಸ್ ಮಾಡುವ. So 46. I think still one more parameter need to be found out. We will do it in the next class. Okay. All of you just mark your attendance in the Google Sheet. So once you mark the attendance in the Google Sheet, you can leave the meeting. Okay. We'll meet up in the next week. Have a great weekend, guys. Enjoy your weekend.
Thank you, sir.
Okay, bye.